All right, so for activity 14.2, cutting parallel lines with a transversal. So you should have already tried to do this on your own, or if you're super confused, go ahead and follow along with me. So these are our parallel lines, which means they're never going to intersect. And then this is what we would call a transversal. It's going to cut the parallel lines and cross through both of them, as you can see right here. So we are just trying to find what are all of the missing angles in this image. So if you did the first activity, you should have remembered that in a perfectly straight line, these two angles are going to add up to be 180. So this angle of 63 plus this angle B should add together to be 180 degrees because it makes a perfectly straight line, and there are 180 degrees in a straight line. So I already know that I have 63 taken from that 180 degrees. So how I'm going to find this missing dash or angle B, I'm just going to do 180 minus 63, and you will get 117 when you do that, which means that this question mark right here is 117 degrees. Okay, so then there's also what we call vertical angles. So vertical angles are angles that are just kind of on top of each other or right next to each other like this. So they're opposites. So that means that this 63-degree angle is the same as this angle right here, which means that this question mark is also 63 degrees, and those are called vertical angles. It's a term that you will have to know for the rest of this unit and then also into next. So these are vertical angles. They have the same measurement, which means these are also vertical angles, which means that this question mark, this angle, is going to be the same as the one across from it, which was 117 degrees. Just like that. Okay? So then we get to how do I find out what these four angles are up here? And that's where we're going to talk about alternate interior angles. So this is my transversal that cut through. Okay? I have this 63-degree angle. And if you look between my parallel lines, this 63-degree angle is on the inside, the interior of those parallel lines. Okay? This is interior, this 117 is interior, and these two question marks are interior. So one thing about alternate interior angles, alternate means opposite, interior means inside. So alternate means on the opposite side of this transversal is right here, this question mark, okay? That means that this angle is the exact same measurement as this angle, which means that that question mark is 63 degrees. And that is because alternate interior angles, this boxed angle and this boxed angle right here, are the same measurement. They are congruent angles. That is only true when I have parallel lines cut by a transversal, which I do. Which also means that this dashed line that was 117 degrees is going to be the same as those question marks, which means that that is also 117 degrees up there. So these alternate interior, opposite of the transversal, interior, inside the parallel lines, are going to be the same degree measure. And then all we have to do is just find these two question marks, which if you look here, it's going to be the same, which means vertical angles. This was 63, so this vertical angle to it was also 63 degrees. If this was 117, based on the definition of vertical angles, this question mark is also going to be 117 degrees. So the question down at the bottom asked, what do you notice about the angles with vertex B and vertex E? Here's vertex E, here's vertex B. Their angle measurements are the exact same. And that again is because we have parallel lines cut by a transversal, which create alternate interior angles, and we also have vertical angles showing the opposite. So I hope this helps. If you have any questions, let me